All right, this one says the slope of a curve. Now, there's the keyword at. So I must be given 1 point. Remember this point here, it is not the same as this. Look, this one, they've got square brackets. Can you see that?
Yes.
Yeah, meaning it's interval notation, meaning this is.
Oh, okay.
Actually, let's put it this way. Let me delete this. This will make it much clearer. If I remove that and I write it as x is an element of, then it makes you know this is the x value as well as that one is the x value. Do you see that?
Yeah.
Yeah.
Yes.
Okay. It's this one. It's not the y value, because when you take the first x value, which is 2, substitute it there, the y that goes with 2, it's a 9. Therefore, that tree would have been wrong if it was y. Can you see that?
Yeah.
Yeah.
Yes.
Yeah, you can check it in that way if you're not too sure. Yeah. It's like this one. You're like, is that the y, that -1, or is it the x?
Yeah.
It has to be the y, because if I put 2 there, square it, it's 4. 4 minus 5, it's a -1. Then it makes sense. This is x, this is y. So I'm only given x1 as just the 2. Now I've got a problem. I don't have another second point. So that means my x2 must be written as x1, which is 2 plus change in delta x. But in that delta x, all I need to do, I need to give it a couple of values. This one, I'll work with 0, 1, 0, 0, 0. Yeah, maybe, yeah, add 1, 0. Maybe you can do it like that, 0, 0, 1, and then 0, 0, 0, 1, and so forth. And then you work it out. Now, remember I showed you this method of a table? I want to show you another one, a quicker one. Here's a quicker method. A quicker one, you keep that delta x as it is. You see that? You keep it as it is. Yeah. Then you're going to do that gradient method, exactly how I showed you. You'll say, okay, that's whatever it is, I'll just call it m for now. You know you need y2 minus y1. Am I right?
Yes.
y2, you must substitute x2, this one. The 2 plus delta x must go in place of x. So which means I'm putting the 2 plus the delta x. Okay, I know it's telling me. Once we do this one, we're good. Remember, they'll use h them. They'll use h there. All right. Yeah. So that equation is -5. So all of that, it's y2, including the 5. You know that, am I right?
Yes.
Okay. Then minus the first, when I put 2 into that equation. Yeah. I need put 2 here. When you put 2, y1 is -1, isn't it? -1. Then we divide. So instead of using those values, you can do it this way. It will give you the same answer. Then we go work out the bottom part. It's x2, which means it's going to be 2 plus delta x. I must minus x1, which is 2. These 2 cancel. You see, you're still left with the delta x, which is the same as h, because you know normally there's always h at the bottom. Am I correct?
Yeah.
Yeah. I forgot to square this one. This one was supposed to be squared. It's actually that method of first principle. All right, it is, but they're not telling you. They're kind of like, you could use this. All right, so now let's open that bracket. I square the first one is a 4, and then double it is going to be 4 delta x, and then plus delta x squared minus the 5 plus the 1. That's the numerator. We good, right, with that one? And then all over the delta x. So this one here, it's -4. Am I correct?
Yes.
It will cancel with that 4, correct?
With the 4.
Then what's left? There is a common factor of delta x. Can you see that?
Yes.
You know it's going to cancel, don't you?
Yes.
Let's cancel it in our heads. So that means here at the top, you'll be left with 4. And then the one with the squared is just plus delta x. So that is that gradient. When they said at, when x is 2, there. Remember, if we were to do it direct, that's what we discovered last time when we had an error. Direct meant delta x must be 0. You see that? That's when you put a 0 here and you say, whoops, oh, the real answer is really 4.
Yeah.
Yeah, so if you had to do 0, 0,01, 0, 0,01, the answer will begin to form. It will be like 4.1, 4.001, 4.00001, 4.00000. It's like, hey, the 4 is repeating. So the answer should be 4. Yeah. So if you don't have, yes, I'm listening.
My question is, can't I just derive the formula and just put the x equals to 2 in?
You can if they ask you to derive. Remember, yeah, this is prior you knew how to derive. It's like you have never known how to derive.
First foundation steps.
Yes. So the assumption is like you don't know how to derive. Yes, you can derive because you already have that knowledge to know what is the answer ahead of time. And then you work it out. If you get stuck, you're like, you skip one of the steps, you just put the correct answer.
Yeah. Yes, like literally.
Yes, exactly. Yeah, they won't make you wrong. Yeah. Yeah, so that was the thing. Other ones, it's the same thing with these ones. Yeah, here it was going to be graphically, but for you to do this one instantaneous, it was going to be the same. They'll say, what is the value at Q? Well, at Q, it's at 10. It's at 10. So at 10, remember here, they did not give you the equation. Can you see that? Yeah.
Yes.
Remember, if it's a graph, when they say at Q1, at 10, you want to put a tangent, in a sense, that touches that point Q1. You want to put a tangent that touches point Q1 there. And then you can, and you say, okay, it's actually here, there. And then you can now work out, like delta y over delta x of a tangent. Can you see that?
Yes.
Yeah. So that means you have to, you can work out a triangle. For example, you could say, maybe I can force this thing to lie on the line. Let's see if we can Hong Kong it. You must try to Hong Kong this thing a little bit. Because it must, if we didn't have a car, I'm doing it this way. So that one of the points is here. Can you see? Yeah, then I say, wait a minute. X is 5, Y is 0 as a point. Then there should be another one you are able to pick. It could be that Q itself. Can you see that?
Yeah.
Yeah, if it's the Q, then you can say it's 10, and then it corresponds maybe with 200 or 210. Let's just say 200 for now. And then you just do that average gradient. Yeah, it's 200. Yeah, y2 minus y1, because that gradient of a tangent it's not a secant, it's a tangent.
Yes.
It is the same as the gradient at that point Q1. That's all you have to do with this one. I think with this we are good. Am I right?
Yes, we're good. Thank you.
Yeah. Okay. Tomorrow we are going to do all those ones of the limits, because there's a limit where you substitute direct a number, a limit where you've got division, you must factorize before you cancel, a limit where you have to with square roots and cube roots, you must take out a number outside from the square root, divide both sides by that, and then you do infinity, positive infinity, negative infinity, limit coming from the left hand side, coming from the right hand side. Yeah. Don't worry, it's gonna be straightforward to the point. I think we're good for a day.
Okay.